Okay, I want you to observe page 3 and page 4, the equations on pages 3 and 4. So on page 3, these are the equations we have. And then we get parabola opening up or down? Opening up. Okay, these are parabolas opening up. Then on page 4, these are our equations. I'm just going to write here at the side. Y equals to negative x squared. Y equals to negative 2x squared. Y equals to negative 3x squared. And we have parabolas opening down, getting narrower and narrower. So comparing the highlighted yellow and green equations, what do you think determines whether the parabola opens up or down? The coefficient. We call it the coefficient of x squared. Okay? So based on your observation, if the coefficient of x squared is positive, how does it open? Up. Does it make sense to you? Why? This is just my observation, but why is it that it will open up? Positive? What about positive? If we try to plot for a graph of y equals to, for example, 3x squared. When x equals to negative 2, 0, 2, and 3. Okay, let's choose these numbers. Can you quickly tell me the values for the first one? For when x equals to negative 2, what is the value of y? What is the value for y over here? Come on, come on. For the graph of y equals to 3x squared. 12. Is it positive or negative? Positive. Because x is negative 2. When I square it, I get positive 4. Positive 4 times 3, I get 12. Okay, so when x is 0, that is obviously 0. When x is 2, x squared is 4. Times 3, we again get 12. What happens when x is equals to 3? 3 squared is 9, times 3 is 27. Can you imagine what happens as I continue with bigger values of x? As x gets bigger, what happens to y? Gets bigger, right? Because whatever you square, it becomes positive. Positive number times 3 will still be positive, and in fact it gets bigger and bigger. So that is why we will obtain a parabola opening upwards. Let us compare with another case where we have a negative coefficient for x squared. This time, let's use y equals to negative 3x squared. What happens when x is equals to negative 2? What is the value for x squared? When x is negative 2, what is x squared? 4. Positive or negative? Positive or negative? Positive, huh? So positive 4 multiplied by negative 3, what do we get? Negative 12, okay? So this is the difference already, huh? Earlier on it was positive 12, now it is negative 12 because of this negative sign. Okay, let's go on to 0. When x is 0, y is also 0. When x is equals to 2, y is equals to negative 12 again. When x equals to 3, y equals to negative 27. What is this pattern that you notice if we were to continue it? As x increases, y decreases. So as you move towards the right, the positive side of the x-axis, your y values gets bigger and more and more negative. So it's a parabola opening downwards. And it all happened because of this sign over here. So the next part, in conclusion, for a graph for quadratic equation that is like this, y equals to ax squared, when a is positive. So this a over here represents the coefficient of x squared. This part tells us that when the coefficient of x squared is positive, we will have, what kind of point will we have? Okay, maybe before we answer that, when the coefficient of x squared is positive, do we get a parabola opening up or down? Up. Okay, so the shape of the parabola looks like this. So does it have a minimum or maximum point? According to this shape, what is the point? Is it a minimum or maximum? Minimum. So here when coefficient of x squared is negative, we have a maximum point. The shape of the graph looks like this. So last one, as the numerical value of a gets bigger, it becomes narrower. John, have you finished? Okay, so let's move on to the next page. Now we have quadratic function y equals to ax squared plus bx plus c. All these means is that it's just a way of writing. A, B, and C are constants. So variations or examples can look like this. Y equals to 3x squared plus 2x plus 1, for example. Y equals to negative 4x squared plus 0x plus 2, for example. So 0x is just no x lah. Okay? So if the highest power is 2, then it is quadratic. We talked about that already. It is a parabola. And it has a line of symmetry. So I need to introduce to you some other terms also. The easier one will be our y-intercept over here. It is the same as what we use for straight line graph. It intersects the y-axis. It is called the y-intercept. In our straight line graph, how do we determine the y-intercept? For example, when I have a straight line looking like this, y equals to 3x plus 4. What is the y-intercept for this case? If I plot this graph out, this straight line, what is my y-intercept? 4. How do you know it is 4? You either say, oh, y equals to mx plus c. So c is my y-intercept. Or you go by logic. At the y-intercept, what is the value for x? At the y-intercept, what is the value for x? 0. When x equals to 0, y equals to 3 times 0 is 0 plus 4 is 4. So this is my y-intercept. Okay? Y-intercepts always happen when x equals to 0. So the same logic can be used for this parabola. To find y-intercept, let x be equal to 0. So for parabola opening up, opening down, same approach. Next, we have the turning point. So turning points, we have two types. Turning point. We have maximum. Okay, in this case, they put minimum first, minimum point. And then we have maximum point. Why do they call it a turning point? Let me show you why they call it a turning point. I'm going to draw tangent lines. Remember tangent lines? I told you to cut using scissors, right? Then for this graph on the left, the tangent line looks like this as I move along the graph. Okay, so initially it looks like this. It is sloping downwards. The gradient is positive or negative over here? What's the sign of this gradient? Positive or negative? It is sloping downwards, so it is negative. Okay, so it is negative, 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 negative. When it comes to this point, what is it? What is this gradient? 0. It is flat. On flat ground, the gradient is 0. The slope is 0. The steepness is 0. So from negative, it became 0. What happens as I continue to move? Positive now. So it changed from negative to positive. And this is the point where it turns in the other direction. Okay? So similarly for this graph over here, what is the original gradient? Positive or negative? This part. It's sloping up, right? So positive or negative gradient? Positive. So as I continue to move, the gradient gets smaller and smaller, closer to 0, and when it comes to this point, what is the gradient? 0. Then now it changes direction already. What happens to the gradient now? Negative. So it turned from positive and it turned to negative. That is why we call these 2 points turning points. This being a minimum point and this being a maximum point. Next term that we have are roots. Roots are simply solutions. For these 2 cases, we take the roots to be the x-intercepts. Okay, just take note of this term, roots. We will come across it later on. So for now, you can write that roots equals to solution. This is an important diagram because every time you draw, you are asked to sketch a graph, you must show all these things. Okay? You must have the y-intercept. You must have the x-intercepts. You must have the turning point. And it must be symmetrical along the turning point. So symmetrical along the turning point. It must cut. Okay? Then let's talk about the symmetrical properties. I'll just have some examples over here. X. Okay, so if this is, for example, y. If this is 3 and this is the minimum point, if this is 3, what must this be? What is this over here? Negative 3. Okay, good. Okay. 100. Okay, so now I'll change the question slightly already. My y-axis is no longer here. Okay, but my line of symmetry, it still passes through the minimum point. Now my y-axis is, let's say, here. This is 0, this is y, and let's say this is 2. Then what is this value? This being negative 1. Okay? So can you tell me what is this unknown, this other x-intercept? How much? Negative 3? Negative 4? So I have 2 options right now. I have 2 suggestions from your negative 3 or negative 4. Can I have a show of hands who thinks it is negative 3? Okay, how about negative 4? Any other answers? No other? Kason, do you have an answer? Okay. So this dotted line, what does it represent? Line of symmetry. How many units are there over here? How many units? Are you sure too? Look closely. How many units are there? 3 units, 1 unit here and 2 units over here. So there are 3 units here. How many units must there be over here? 3. So from negative 1, you minus 3 units, what do we get? Negative 4. Okay, so this is how we also use the symmetrical properties of a parabola to determine the x-intercept. It's one way to do it. Okay, back to the notes. If the coefficient of x squared is positive, it will take a parabola opening upward shape with a minimum point. Okay, so all this we've done already. Now let us fill in the blanks over here. We can do it really quickly. For the first one, y equals to negative x squared plus 1. This is a quadratic equation because there is a x squared. So is it parabola opening up or down? Up or down? Down. Like this. So describe the turning point, maximum or minimum? Max. Okay, next one. Opening up or down? Up. Minimum or maximum? Last one. How do you know it is up? How do you know it is up? Or how do you know it is down? I need the coefficient of x squared, right? But it has to be in the form y equals to ax squared plus bx plus c. At the moment, do we have y equals to ax squared plus bx plus c? No. So can you make y the subject? So here we have y equals to negative x squared minus 1. Okay, so since it is y equals to negative x squared, then what is the shape? Opening up or down? Down. And we have a maximum point. Any questions? In that case, let us move on. Y-intercept is when x equals to 0. Same case for our straight line, y equals to mx plus c. This is a straight line. So the quadratic equation always has one y-intercept. No matter how you draw your parabola, it will cut through the y-axis. So this will be our y-intercept. Can you draw a parabola that doesn't cut through the y-axis? Do you think it's possible? How? Parabola that doesn't cut the y-axis. At the side? You mean like this? Y and x. Does it cut the y-axis? What am I supposed to do? We say that this is a parabola that opens upwards. Does it ever stop? No, it doesn't stop. Does your y-axis stop here? No, your y-axis continues forever also. So it continues up, up. This also continues up, and it will cut sometime or another. Okay? Okay, so we'll stop over here.